Hello everyone, in this video we are going to discuss our first problem of fixed size sliding window. I have discussed about the introduction of sliding window and why we use sliding window in my previous lectures. For any doubt you can consult those lectures. Okay, so we have talked about two types of sliding window, and those two types are like fixed size and variable size. We took an example of both. Now we will take one direct example of fixed size sliding window. Let's suppose the question is we need to find a maximum sum in subarray of size k. Let's take the question. The question is maximum sum in subarray of size k. ये मैक्सिमम भी दे सकता है, मिनिमम भी दे सकता है. नथिंग विल चेंज, लाइक यू विल जस्ट चेंज योर मैक्सिमम टू मिनिमम while calculating the answer, and yeah, rest will remain the same. Okay, देखते हैं कैसे कर सकते हैं. First of all, let's look on the brute force approach. Like, let me say you the array 1 2 4 2 1 3 7 8. Let's say the array is this and the value of k is equals to, let's say 4. The window size is 4. Now what is the brute force approach? सबसे पहले अगर किसी को स्लाइडिंग विंडो नहीं पता तो वो क्या करेगा? ही विल स्टार्ट फ्रॉम हेयर, ही विल ट्रैवल 4 एलिमेंट्स एंड ही विल टेक द सम विल कम आउट टू बी 9. यहाँ से सम जोड़ लो ना 4 को, तो सम 9 आएगा. 9 विल बी द सम, एंड या ही विल कीप वन मैक्सिमम वेरिएबल इनिशियलाइज टू इंट मीन. यही करते हैं ना, मैक्सिमम निकालना है तो इनिशियलाइज इंट मीन से करते हैं, एंड जो सम अभी आया उसको आंसर से मैक्सिमम ले लेते हैं. सो आंसर 9 हो जाएगा. द आंसर विल बिकम 9. नाउ ही विल कम टू 2. ही विल अगेन टेक द सब array ऑफ साइज 4. ही विल कैलकुलेट द सम. ही विल गेट सम एज अगेन एज 9. ही विल कंपेयर विद आंसर. ओके, इक्वल है, कुछ नहीं करना. नाउ ही विल कम टू 4. ही विल अगेन रन द लूप 4 टाइम्स एंड ही विल कैलकुलेट द सम. ही विल गेट सम एज 10. अच्छा, आंसर से ज़्यादा है, आंसर को अपडेट करो. चलो कर दिया अपडेट. He updated the answer, right? Now he will again come to 2. He will again run the loop 4 times. He will again calculate the sum. He will get sum as 13. Okay, answer को update करो, 13 हो गया. Now he will come to 1. He will calculate the sum. He will get the sum as 19. He will again update the sum. अब वो 3 पर तो नहीं आएगा, इतना तो दिमाग है कि 4 बार ट्रैवर्स ही नहीं कर पा रहे तो आगे तो नहीं बढ़ना. Okay, so yeah, this is the brute force approach, isn't it? ब्रूट फोर्स. ब्रूट फोर्स किसको बोलते हैं? जो देखते पहले ही दिमाग में आ जाए. अगर कोई उस टॉपिक से रिलेटेड नहीं पता, ऑप्टिमाइज्ड अप्रोच, सो वी टॉक ऑफ ब्रूट फोर्स. इंटरव्यूज में पहले हमेशा ये डिस्कस कर देना. ऑलवेज ट्राई टू डिस्कस दिस अप्रोच फर्स्ट, सो दैट वंस यू ऑप्टिमाइज इट क्रिएट्स अ गुड इंप्रेशन इन द माइंड ऑफ इंटरव्यू. ओके, सो इसका टाइम कॉम्प्लेक्सिटी कितना है? व्हाट्स द टाइम कॉम्प्लेक्सिटी? इज नथिंग बट बिग ऑफ n मल्टीप्लाइड बाई k. फॉर कमिंग टू एवरी इंडेक्स यू आर ट्रैवर्सिंग इट k टाइम्स. अब ये मत देखो कि लास्ट वाले के लिए ट्रैवर्स ही नहीं किया, इट्स वेरी लेस. फॉर एग्जाम्पल कुछ लोग ये भी बोलेंगे कि बिग ऑफ n माइनस k इंटू k है. सो या इट इज सेम एज बिग ऑफ n क्रॉस k, इजंट इट? सो या दिस इज द टाइम कॉम्प्लेक्सिटी. ओके, नाउ हाउ टू ऑप्टिमाइज इट. ऑप्टिमाइज कैसे करें? ऑप्टिमाइज हो सकता है कैसे, वो कैसे पता चलेगा? हाउ यू कैन हैव द फीलिंग दिस कैन बी ऑप्टिमाइज्ड. सी, you are doing 1 plus 2 plus 4 plus 2 from here, and in the next sub array what you are doing is 2 plus 4 plus 2 plus 1. so again you are doing this repetitive work ना. so इसको ऑप्टिमाइज किया जा सकता है. कैसे करेंगे ऑप्टिमाइज? I have discussed it before. You will keep one starting value, you will keep one ending value. Now ending value can be maximum go to index n minus 1, isn't it? इतना तो पता चल रहा है कि ending maximum window का जो ending है वो इसको यहीं जा सकता है. ऐसा तो नहीं कि आपका घर का दीवार, घर का विंडो घर को छोड़ के कहीं और ही चल जाए. सो योर विंडो कैन मैक्सिमम बी इन योर हाउस, राइट? किसी दूसरे के घर के विंडो को अपना विंडो नहीं बोलना है, and you need to only talk about your own window right over here. Okay, so this j can maximum go to n minus 1, so we will keep a check of j less than n. Now what you will do is you will calculate the sum. Initially you will keep your sum to 0 and you will have an answer variable which is initialized to int me. Now what you will do is, you will take the sum of the present element you are in. Okay, now what you will do, you will just check the window size. If the window size till now you have taken is like, let's suppose the window size is less than k, like अभी तक विंडो पूरा बना ही नहीं, तो उसको छेड़छाड़ करने की कोशिश मत करो, गिर जाओगे तो प्रॉब्लम हो जाएगा. ओके, सो लाइक विंडो साइज अभी तक के साइज का बना ही नहीं, सो इन दैट केस सिंपली कंटिन्यू. लाइक अभी कुछ वर्क नहीं करना, कुछ करने का कुछ फायदा नहीं है, बिकॉज अभी तक हम लोग का विंडो बना ही नहीं है. नाउ वंस यू क्रॉस दिस कंडीशन, लाइक वंस यू क्रॉस दिस इफ लूप, कंटिन्यू करने से क्या होता है, अगेन इट विल गो टू वाइल लूप, राइट. बट कंटिन्यू करने से पहले एक चीज ध्यान रखना है, यहाँ j प्लस प्लस कर देना, because you need to go to the next element, right? So yeah, this is when the window size is not completed. Let's suppose the window size is completed. So what you will keep the check is, while like window size fixed है ना, just say me one thing, while window size is fixed, since window size is fixed, so can you say कि अगर suppose कर लो आपने यहाँ पे k elements लिया था, so yeah, you will keep your answer and your window size is k. Let's suppose your window size is k and आपका window size k हो गया था, तो आपने आंसर में जो required answer है कुछ था उसको स्टोर कर लिया, you stored the answer. Now when you move to the next element, your window size becomes k plus 1. So just tell me how many elements you need to shift. Just tell me one thing, how many elements you need to shift. You need to shift only a single element, isn't it? Like एक बार आपका window size k हो गया, so and whenever you take the next element, you always need to shift your I by only one, right? So what you will do is, when window size becomes k plus 1, you will shift I one step forward and your window size will again become k. I का contribution को हटाना है, वो भूलना मत. Like you need to remove the contribution of I, isn't it? Okay. So like this is the like template of using the codes, writing the codes for window size fixed. Like once you reach the window size, now whenever you exceed the window size, you will always need to shift your I by only one step forward, because that will restore the window size again to k, isn't it? So yeah, so we can keep a check, like if j minus I plus 1 is like greater than k, like window size is greater than k, so we know that we only need to shift the window only by one size. So like in this case, we will subtract that number from our sum. Like I का contribution हटाना है ना, हटा दिया हमने, and you will just shift your I. Okay. And once you are done with it, now you know that your window size is k. So just you can store in answer the maximum of answer you got and the sum you have till now. Like in this window, this is the sum, and you have some answer from before. So yeah, you can calculate the sum. Let's dry run for this part, like 1 2 4 2 1 3 7 8, and you will understand it better. So let's just take this array 1 2 4 2 1. 1 2 4 2 1 3 7 8. Let's try run for this part, and you have the window size as 4. Okay. So हम लोगों का I यहाँ है, we have our I over here and J over here. जब तक J minus I plus 1, that is window size 4 नहीं हो जाता, until we have reached the window size, we will just add the values to our sum. Initially the answer is equals to int b, and we need to find the maximum sum, isn't it? Okay. We took the 1, the sum became 1 plus 2 plus 4 plus 2. जैसे ही 2 पर आया, window size becomes equals to 4. So yeah, we will like sum अभी तक कितना आया है, 9 आया. So we will store the maximum of answer comma sum, and it becomes 9. Now when you come to 1, you get that window size exceeds 4. So you know you only need to shift one element. Like when you come to this, you add this contribution. Now the window size increases to 5, and you know that you only need to shift one element forward. So just you will shift your I over here, and before shifting, you will remove its contribution. Okay. So yeah, after doing this, you again know that your window size is equals to 1. You will calculate the sum you achieved till now, and it's 8, and you will take as answer equals to max of answer comma sum you got till now. Okay. So yeah, this is the thing you are going to do, right? Okay. So like what is the sum? Your sum is over here is 9. 1 plus 2 plus 4 plus 2 plus 1 minus 1. This 1 and 1 gets cancelled, and your sum is 9. And again you will get answer as 9 only. Answer will stay as 9. You again come to J over here. Now when you come to j, you check the window size. Like first of all, you add the contribution of j, you check the window size, it exceeds the value, so you know you need to shift your I only one step forward. You will shift your I before that you will remove its contribution, and you will calculate the sum. At that time it's 8, and when you take the maximum it will stay as 9, because yeah, definitely 8 is less than 9, isn't it? Now when you again come to j, you first of all add its contribution. Now after adding its contribution, you know that you have exceeded the window size, so you will again shift your I over here, and like your I was here, right? So you will shift your I over here, and before removing the before shifting I, you will just remove its contribution, and so on. You will get the sum as 13. You will store the maximum of answer comma sum, and it will get updated to 13, and so on. So this is the approach of like fixed size sliding window, fixed window size. You know, like ये लॉजिक है ना, सिंपल है. वंस यू हैव कंप्लीटेड द विंडो एंड वेन एवर यू एक्सीड, लाइक अगर मैंने आपको बोला कि आपको के साइज का विंडो बनाना है, एंड वेन एवर यू एक्सीड, तो एक्सीड वाला कंडीशन जब आप k+1 साइज का विंडो बना लोगे तभी मिल जाएगा आपको कि एक्सीड कर गया है. सो यू ओनली नीड टू शिफ्ट वन एलिमेंट, राइट? एंड बिफोर शिफ्टिंग दिस एलिमेंट, जस्ट रिमूव इट्स कंट्रीब्यूशन. सो लेट्स कोड इट डाउन वंस एंड यू विल गेट द आइडिया. Let's take the size of the array in n and let's take the input of the array. Okay, so now अपना starting value एक रखते हैं और ending value रखते हैं window का. The ending value of window can maximum go to index n minus 1. So we will keep a check, like j is less than n. We will go up till only there. Okay, the question is we need to calculate the maximum sum, isn't it? So the answer will be initialized to int mean, and like the sum we got till now in this window, like we have not started the window, right? So the sum we got till now is 0. First of all, when we come to j, we will take its contribution in our sum. Now we will keep a check, like if the window size till now is less than the required window size, let's take the window size from the user. User, tell me the window size. Okay, user has given me the window size. So if this is the case, we have not filled the window till now, we will just continue from here, and before that we will increment our j to go to the next element. Okay, now if the window size is not, like window size is filled, so there can be two more cases. Like if the window size exceeds the value of k, so we know that if exceeds the value of k, we only need to shift by one element, so we will just remove the contribution of that ith element, that is the starting element, and we will shift our I. And once we are done with this, we will store our sum. Like now we know that the window size is exactly k, isn't it? So we will store that in our answer. The sum is, answer is equal to maximum of answer comma sum. And yeah, at the end we also need to do j++, since we know that we need to shift to the next element. And once we are done with it, we will just print our answer. Okay, so let's take the inputs. Let's take the same input we discussed over here. We have the array size is 1 2 3 4 5 6 7 8. The array size is 8. Array size is 8 and the size of the window is 4. The array elements are 1 2 4 2 1 3 7 8. Okay, so let's run it once. What is the maximum size of like 4 size window? Sum we get. Okay, it's giving me 19. Is it 19? Let's check. Like yeah, if you take this window of size 4, you will get the maximum sum, which is 19. I hope it is clear. Like if you check, change the value like something to 1 over here, and let's check the value now. Like you also change this to 1, and let's suppose you change this to 2. Now yeah, let's calculate the windows maximum sum of window 4. The value is 11, and you can see that yeah, this is the window of size 4 whose value is 11. So this is the approach. What is the time complexity of this code? Like you will run this I maximum of n times, and like maximum of n times, not n for every n. So the time complexity of this code will be big of n plus n, बिकॉज आई तो आप एक ही बार 0 से n तक लाओगे ना, ऐसा तो नहीं है कि बार बार ही लाओगे. सो यू विल रन आई ओनली n टाइम्स एंड j ऑल्सो यू विल रन मैक्सिमम ऑफ n टाइम्स. सो big of n plus n which is equals to big of n, isn't it? So time complexity is big of n. The another way was like we start from every element and run the loops k times. Like if you want me to write, like I am writing the another way also, and you will see like how cumbersome it is. Okay. Let me write a different approach for you, the brute force one. So like for int j equals to 0, like this is the starting element of the window. So for int I equals to 0, I less than the maximum the starting element can go to n minus k, isn't it? And I plus plus. So it will be equals to n minus k, I plus plus. Now what you will do, you will keep a sum initialized to 0. Now for every j, for int j equals to 1, j less than j equals to I, j less than equals to j less than I plus k, okay, and j plus plus, what you will do is you will keep the value in sum, and once you are done with it, what you will do, you will store your answer as maximum answer comma sum. I hope you are getting it. Like for coming to every index, we are running the loop k times and we are checking our answer, and at the end we can see out our answer. So yeah, this is the brute force approach, isn't it? What is the time complexity of this code? It is nothing but big O of n. Like for every n index, we are multiplying the loop k times. Okay. So yeah, this is the brute force approach, and the one we discussed earlier was an optimized approach, a sliding window approach, and hope like you all are now just getting familiar with sliding window, and you will get more and more comfortable once we discuss more questions. Okay, for now, let's end over here. Thank you.